Assalamu alaikum. The topic we are going to cover in this lab session is lab number 7, that is to construct a network and demonstrate successful connectivity between hosts where OSPF is configured in routers using Cisco Packet Tracer. We have already configured RIP, which is a type of distance vector protocol. In this session today, we will look into OSPF details and configure it on routers to show the successful connectivity. The lab has some objectives as well, which we will be able to achieve at the end of performing tasks. Firstly, you will learn a new routing protocol, that is OSPF, and can implement it on Packet Tracer. Secondly, after implementation, you can show the connectivity of routers using Packet Tracer. Lab number 6 is mapped on two course learning outcomes. First one is Lab CLO1, that is mapped on PLO5 with level P4. This mapping is same as the last lab. And second mapping is on course learning outcome, which is mapped on PLO10, as lab reports are evaluated using this CLO. Now let's move towards our topic. From previous labs, we know that dynamic routing is divided into two broad categories, that is interior gateway protocols and exterior gateway protocols. Interior gateway protocols run within an autonomous system and are further classified into two different categories, which are distance vector routing protocol and link state routing protocol. We have already studied distance vector in detail along with RIP and configured it successfully. Today, we will discuss link state routing protocol in detail and configure or test OSPF in routers, which is a type of link state routing protocol. In link state routing protocol, every router originates some information in order to compute its table, to discover the best path and to know about remote networks. This information is about itself, its directly connected links, and the state of those links. From this information, its name originates as link state. This information is passed from router to router. Each router makes a copy of it but never change in this information. As a result, at the end of this exchange, every router has identical information about the internetwork. And from this information, each router will calculate its own best path. There are three main steps or points in link state routing protocol. First is neighbor relationship or knowledge about the neighbors. Second is flooding, that is to send some packets to every router except neighbors. Every router that receives packets sends copies to all of its neighbors. The third step is information sharing. This is done only when there is a change. As we see that first point is neighbor relationship, so the first step in getting link state up or running is neighbor discovery. Now how it is done? Let's consider two routers A and B. They are potential neighbors. So in order to build a neighbor relationship, router B sends a hello protocol to do so. It will define a hello packet format and a procedure for exchanging the packets and processing the information that packet contains. At a minimum, the hello packet will contain a router ID and an IP address from one of the router's interfaces. Other fields may be a subnet mask or a hello interval, which is a specified maximum period the router will wait to hear a hello before declaring the neighbor dead. When two routers have discovered each other as neighbors, then hello packet serves as a keep alive to monitor adjacency. Adjacency is a term used to refer a common region or relationship of one router with the other. If hello packets are not received in certain established time, the neighbor is considered unreachable. Hello packets are exchanged after every 10 seconds, and the time after which neighbor is considered to be unreachable is known as dead period and is 4 times of the exchange time. So, after neighbor relationship or neighbor adjacencies, link state has two phases. First is reliable flooding and the second is path or route calculation. Let's see what is flooding in link state. Once adjacencies are established between neighbors, router may begin to send link state advertisements. What are link state advertisements? A small packet of routing information that is sent between neighboring routers are known as link state advertisements. Link state advertisements are sent to every neighbor, and once it is received, LSA is copied and forwarded to every other neighbor except the one which originally sent LSA at first place. This is source of link state's advantage over distance vector. For the same reason, it converges faster than distance vector. There are several ways to make flooding more efficient and reliable. For example, unicast, multicasts are used, checksums are used to avoid errors, positive acknowledgements are used to make sure that it is received, sequence numbers are used, and another term, aging, is used. Age is set as 0 when LSA is created. Each router increments it by 1. Aging adds reliability to the link state advertisements. Now the next point arises that when to flood link state advertisements in adjacencies. Either there is a topology change, that is link or node is failed or recovered from error, or configuration change, link update the link metric, or they may be sent periodically to neighbors, for example after every 30 minutes. This can also correct the possible corruption of data. Now, what are challenges faced during flooding? There may be a packet loss or LSA is arrived out of order. These problems can be solved using acknowledgements and retransmissions in case of the lost packet, and out of order arrival can be corrected or avoided using sequence numbers. Time to live timers can also be used for each packet.